now we're going to focus on still multiple representations, which are tables, graphs, equations, scenarios, but we're more focused on the unit rate. That's how many per one. Another reminder that this week it is 3 topics. I already covered proportion concepts with you guys. We're working on the unit rates now, and then independent and dependent quantities will be on Thursday. The only new vocabulary for this, which isn't totally new, is proportion, which is 2 equivalent ratios. So think equivalent fractions. And they have a multiplicative thinking, which we discussed in the previous lesson. A unit rate is how much per 1 unit of something. So you see unit rates all the time at the grocery store. The price of an item is a unit rate. How much you make per hour to work is a unit rate. Something that is not a unit rate is 200 miles in 4 hours, because that's 4 hours, not 1. So if you divided that to get 50 miles in 1 hour, that would be your unit rate. So let's do a few examples. If you can bake 40 loaves of bread in 5 hours, how many loaves of bread can you bake in 1 hour? So unit rates are basically just division. If I can bake 40 in 5 hours, how many can I bake in 1? So I can figure out that 5 divided by 5 equals 1. And what I do to the top, I do to the bottom. So I'm going to divide 40 by 5, and that will give me 8. I can bake 8 loaves of bread in 1 hour. That's considered a unit rate. If I continue with the unit rate thought process, and if I can bake 40 loaves of bread in 5 hours, remember we were at 40 in 5 hours, which was the same as 8 in 1 hour, can I use that to figure out how many in 7 hours? Okay, so notice that if I try to go from 5 to 7, it's not friendly at all. But if I go from 1 to 7, that's extremely friendly. I multiply by 7. So therefore, I would multiply by 7 here, and I would get 56 loaves of bread. So, sorry, my handwriting is really bad on the screen. So unit rates can help us with proportional concepts, because we can basically break down the original to get the unit rate and then use that to build up to our new ratio. Okay, so let's look at some more complex examples. If it takes 2 gallons of water, so we're going to say gallons and plants, and if it takes 2 gallons to get 21 plants, they want to know how many to get 35 plants. So I'm going to start by thinking, I know it's more than 2, because 2 gave me 21 and 35 is larger than 21. But if I do 4, that's this times 2, right? So this times 2 is going to give me 42. That's too big. So I know it's in between 2 and 3. Let's see what 3 would be. If I do 2 over 21 equals 3 over, we don't know. Can I multiply something times 3? I mean, something times 2 to get 3? Ugh, I can't talk. 1.5, right? Okay, so let's do 21 times 1.5. 5, 10, 0, 1, 2. That gives me 31.5. Okay, so 3 would be 31.5, and I'm looking for 35. So I know it's a little bit bigger than 3, okay? I can then figure out the unit rate, right? So if I do 21 divided by 2 to get a unit rate, what's half of 21? 10.5, right? And then I would do that times, I've lost my train of thought, I apologize. Oh, scratch that. I had a brain fart. Let's do that a different way. All right, so my apologies. I am having a moment. If I divide that by did all this last night and now I've lost my train of thought. Oh, that's right. No? Okay. I'm losing my whole mind, I think. I know the answer is 3 1/3. I just can't remember from my notes how I got there. Let's see here. All right, I did 7. Where did I get 7? I divided both by 3. Yeah, that's what I did. So I had this divided by 3. That's an eraser. This divided by 3. Still an eraser? Oh, a highlighter. I'm having a day. This divided by 3 would give me 2/3. And this divided by 3. Oh, I erased something. That's what I did. That was 21. This side's 2/3. This side is 7. So I know I can multiply 7 times 5 to get 35. So I multiplied 2/3 times 5 to get 10/3, which then equals 3 1/3. I really apologize for my brain fart. I don't know what I'm thinking. Good news, you don't need that one on Imagine Math. So let's move on. You'll notice that these were snipped directly from your Imagine Math, so you might want to take some notes. When we're looking at a graph, unit rate is fairly easy when your x values are counted in whole numbers, because all you really have to do is find your x value of 1 and then look at your y value, and then you put y over x. That's the constant of proportionality. Okay, so my y value here is 52. My x value is 1, which the 1 is what makes it a unit rate. The 1 underneath it makes it a unit rate. And so therefore, now I just got to attach words to it. It's 52 watts per 1 watt. In this case, it's miles per 1 hour. Okay, so in this scenario, whatever's traveling is traveling at 52 miles in 1 hour. Anything mph, mile per hour, is a unit rate. So it's fairly easy on a graph as long as it's labeled in whole numbers. If it's given like this, and they didn't give you that whole number value right here, and it doesn't fall on a perfect clean point right here, we can take the information they did give us, create a table. Our x value, we have a 3 and a 4. Our y values are 201 and 268. And we can determine how it's changing. So what's happening to go from 201 to 268? We're adding 67. Okay? Here, we're just adding 1. So if I'm going from 3 to 4 and adding 67, can I work backwards and determine what 3 to 2 would be? Yeah, I can subtract 67. And what is that? 201 minus 67 is going to give me 134. So at 2 hours, we're at 134. And then if I go down again and subtract 67 again, it's actually going to give me 67. So at 1 hour, we're at 67 miles. So that is our unit rate. Therefore, the car is traveling at 67 miles per hour, and that is our unit rate. Okay, so you find the rate of change from the table, and then you use it to work backwards to find your unit rate. Okay, we only have a few more slides. If you make $97.75 for working 8.5 hours, what is your rate of pay? So $97.75, remember if you work 0 hours, you get $0. So we just divide to determine what our rate of pay is. I prefer that y'all try to divide by hand because you aren't going to be using a calculator. But if you'd like to check your work before you click it on Imagine Math, I can understand that because it does take away quite a few points. So 85, start by moving your decimal. So my decimal is now right here. 85 can go into 97 one time. Subtract, that leaves me with 12. Bring down the 7. It can go into 127 one time. Subtract, that gives me 42. Bring down the 5. And 425, 85 can go into 425 exactly 5 times. So my rate of pay is $11.50. Okay. If you can walk 1/4 of a mile in 1/8 of an hour, how long will it take you to walk an entire mile? Okay. So we have hours. And we have 1/8 of an hour to walk 1/4 of a mile. And they want to know how long to walk an entire mile. What do I multiply 1/4 by to get 1 whole? I multiply it by 4. So what I do to one, I have to do to the other. So 1/8 times 4 is going to give me 4/8, which then equals 1/2. So you can either say 1/2 hour or 30 minutes. But I'm going to leave it in hours since the question was given in hours. So it takes 1/2 hour to walk a whole mile. All right, last slide. You'll notice that this is directly from your Imagine Math. So notice it is proportional because it goes through the origin. And it says the unit rate for the trip is 40 miles per hour. Did they give us the unit rate? No. But can we divide 60 by 1.5? We can. And if you're pretty good with your multiplication facts, you'll realize, or even looking at a clock, you'll realize that 60 divided by 15 equals 4. So if I divide both of them by 1.5, it'll give me 4/1. Or 40/1, sorry. So this one is true. The unit rate is 40 miles per hour. It takes 30 minutes to go the first 20 miles. Well, 30 minutes is 1/2 hour, right? So if I divide this by 2, it'll give me 1/2. If I divide 40 by 2, it'll give me 20. So that one is also true. Your speed is 90 miles per hour. Well, we just discussed that it was 40 miles per hour, so that's not right. That's false. And last, at this rate, it'll take 2 hours to go 80 miles.